So first of all, Johar and welcome everyone. And in this video, I will show you how to apply BFS on a graph stored in adjacency list format. And for that, we will first create the graph to store the vertices, edge and vertices. So I will also show you how to create the class and how to store the graph, and later on how to apply BFS on it. So let's begin. First of all, let's begin by creating a class which will store the graph. So let me name it graph itself. So okay, so now what are the public variables it will have? First, it will have number of vertices, number of num vertices. Okay, and second, let me define the constructor. So constructor is a special method which is the same name as that of a class, and it will be called whenever an object is created. So we want to take num from user, like num will be the number of vertices. So I will assign number of vertices to be num, that is user will give this num. So now next, after creating the constructor, I need a function edge, like to add edge. So let me create a function to add edge, and it will give two values, u comma v, that is u is connected to v. And first let me define how we are going to store the graph. So we are going to store it in a adjacency list format. So adjacency list format, it will be a vector of vector. I will explain how it works. Adjacency list. Okay, so now I'll have to include vector. Space std. Okay, so now this one is the adjacency list, and it will have elements like 3 is connected to 1, 2 and 4. Then 2 will also be like this only. If 2 is connected to 3, 3 will also be connected to 2, 3 and maybe 4. Okay, so like this. So we'll get u is connected to v, like 3 is connected to 4. It is a non-weighted non-directional graph. So 3 is connected to 2, so 2 will be also be connected to 3. So now to add this, now what we will do to add this, we will just adjacency list dot push back. Now adjacency list of, okay, in u we have to push back v, and in adjacency list of v we will have to push back u. Now the graphs are stored properly. Now u is connected to v and v is connected to u. Now these two methods are built. Now next I will build BFS. So it won't return anything, so let me name as BFS, and we'll get a start, like from where to start. Now for BFS we need a visited array. Now the main job of visited array is to check which are the vertices which we have already visited, and we are not going to traverse it again, because in BFS we traverse each vertex only once. Okay, now for that also visited array also will create using vector itself. So it will be vector int visited, and the size of visited will be, at first it will all be false, and the size will be num vertices. I think it's opposite. So size will be num vertices, and all will initially all of them will have false value. So now next, now we also need a queue to keep track, because in BFS what we do is that we first push the starting node into the queue along with all its neighbors. Like first, if A is connected to B, C, D, we'll push A, then after that B, C, D also will push in the queue. And the property of queue is first in, first out. So the first node that will be pushed into, queued into the queue, that will be the first one to exit. So let me first make a queue of int type and let me name it as queue. So next what we will have to do is that first we have to check visited of start. We have to, yes, visited of start. So this is key. So if the key doesn't exist, it will be created and it will be set to true. Okay, now this much is done. Now, and we'll also have to push the start into the queue. Queue dot push start. We'll have to include the queue, include queue. Okay, now this much is done. Now the main part. Now while queue is not empty, while queue is not empty, okay, now while queue is not empty, what we have to do is that first current node we will get current node from queue dot front. Queue dot front is the function which will return the element which is in the front of the queue, and current node, and next we will have to pop that. Let it is, we'll have to take that out of the queue. Now after that we will have to see out the current node, that is we are writing, we are traversing there. Next we'll have to add all the neighbors of that node to the queue. So all the neighbors of the queue for auto I in adjacency list of start, no, not start, current node, if I is not visited, if visited of, so let me rename this, otherwise we'll get confused. So this is all the neighbor, any so this is all the neighbors. So okay, so all the neighbors. Now I need to see if the visited of neighbors, visited is our visited array, visited, so we will see visited. Okay, if it's any is typo here, it should be visited. So okay, if it's not visited, then push it into the queue dot, push it into the queue, and we'll have to push the neighbor, NEIGHBOUR. Okay, we push the neighbor and we set, okay, we push the neighbor, and after we push the neighbor we set it's visited, like we have visited here, visited of neighbor to be true. Okay, this much is done. Now what we have to do, now queue is, VFS is almost complete. So let me reiterate what I have done. So first we need a visited array, and why we need a visited array is to keep track of how many vertices we have already visited and we don't want to visit them again. Next, queue. Now remember, whenever you think about BFS or hear the term BFS, the first thing that should come into your mind is queue. In BFS we use queue. In BFS we use queue data structures. Okay, so visited of start equals to true. Now what this line means? This line means that we are setting the start of visited array to be true, so that we know that we have already visited this node and we don't want to visit it again. Now, as I have already told, in BFS queue is used, so we'll have to push that node into the queue. And how BFS works is that first I'll push the start node, then after I push the start node, I will push all its neighbors that are not in the visited array. I'll push it inside the queue. So the property of queue is first in first out. So first I have pushed queue, I have pushed start, so start will come out first, then after that its neighbors that get pushed after it. Now this should work fine. Now here we have to just define the graph. Okay, so here we need to define the graph. So let me just define the nodes to be, let's say we have only 5 nodes. Okay, 5 nodes, and let me create graph named n. Okay, let me give a better name, grph. Okay, now graph dot add edge. What is the name of the function that I have given? Yeah, it's add edge. So here first I will add 0 is connected to 1. Okay, now 0 is connected to 1, then next will be 0 is connected to 2, then grph dot add edge, then maybe 1 connected to 2, then 2 connected to 4, then okay, 1 connected, let me give just 1 connected to 3, connected to 4. Okay, so, and after that I have to call the function grph dot bfs, and I want to call it from 0. Okay, 3 4 5 6. Okay, let me run it. Some error, that is line 27, I have some error. So visited. Okay, so this one should be visited. Oh yeah, I need to pass how many nodes are going to be there. Nodes. Okay, yes. Next, segmentation fault. Okay, I need to resize it. I'm not resizing the size here. So adjacency list, I need to resize it. I need to tell what will be the size of that. So adjacency list dot size of the adjacency list will be none. Okay, let's see. Okay, it ran successfully. So now I'll also add the graph that I have written. So 0 is connected to 1, 0 is connected to 2. So it starts from 0, then 0 is connected to 1, so 1 will come, then after that 2 will come. Now 1 is connected to 2, 2 is already visited, 2 is connected to 4, 1 is connected to 3, so 3 will come, then after 3, 4 will come. Okay, so this is the correct order. So let me explain the code again. So here we have saved the graph using adjacency list format. So in adjacency list, so adjacency list is a vector of vector. Adjacency list is a vector of vector. Okay, and it's a vector of int format. So now I have saved it here. So what this function is doing, so what this function is doing is that it is a constructor, and it is assigning the number of nodes we are going to have in the graph. So the user will give this, like here I have given nodes to be 5, so we'll have 5 nodes, and we'll assign this variable number vertices to be 5, so it's coming from here. And we will also have to give the size of the adjacency list. So now here we haven't defined what will be the size of the adjacency list. So in this line we are defining that the size of the adjacency list will be num, it will be num length, that will come from user. Now this is add edge. Now what this function is doing is that it is adding an edge. So as I already told you in this example, like 3 is connected to 2 and 2 is connected to 3, so it will 2 will go into adjacency list of 3 and 3 will go into adjacency list of 2. So now u is connected to v, so in adjacency list of u we are pushing back v, and in adjacency list of v we are pushing back u. Next, BFS. Now this is the main part. Now, so listen carefully, I'll explain. So whenever you hear the term BFS, just think that Q will come into picture. So BFS means Q, and the property of Q is what? First in, first out. So what this line is doing, what this line is doing is that we are defining a visited array. So the purpose of visited array is to keep track of which nodes we have already visited and we are not going to visit it again. So this is the only purpose. So what will be the size of the visited array? It will be the number of nodes that are there in the graph. So that we are assigning it number of vertices, and initially all of them will be false. Then now BFS means Q, so we need a Q. So I have called a Q here and I have named it Q. Now visited array of start equals to true. What this line means? This line means is that we are first assigning the start, like from where we want to start the VFS. Now the start value we are assigning true. This means that we have already visited start, you don't visit it again. Now q dot push start, now we are pushing it to the start. Now here we will not print anything, we'll just push the start into the queue. Now this while loop will run until the queue is empty. So now now we have one element in the queue. So the first thing we do is that we get the first node out from the queue. So to get the first node out from this queue, we'll do q dot front. Now this will give the element which is in the front. So we get the front node and we pop it. Now the queue is empty. Now what we do, we print the queue, that is current node, and after that, this is the important line. Now the queue is empty after we popped it, but we will push all the elements, all the neighbors of the node inside the queue. So now I am iterating over all the neighbors in the adjacency list of current node. So this, from here I'll get all the neighbors that are connected to the current node. And if it is not in the visited array, this line is important. If it is not in the visited array, that means we have not visited that neighbor, we will add it into queue and we will set the visited of that neighbor to be true. So we will do this for all the neighbors. So if all of them are not visited, all of them will be pushed into the queue, and after we push it, we'll come out of this loop, then again we'll go back. Now the queue is not empty, we have pushed all the neighbors inside this queue. So now what we'll do is that we'll just take out the front and we will do this again and again till all the vertices are traversed. So this is the main function of this function. Now what this code is doing is that here I am just assigning, like I'll have 5 nodes, and after that I am creating a instance of the class graph, and the constructor is taking value this node, that is I am going to have 5 nodes, that is 0 1 2 3 4. Now I am adding all the edges, like 0 is 1, 0 connected to 1, 0 is connected to 2, all of them will be added. So let me rerun it again and I'll show you. See, we are getting the BFS to be 0 1 2 3 4. So hope this video helped you. Adieu, bye.